In this video, I'm going to go over Unit 1, Lesson 4, which is about expansion. It's another word that means distribute or FOIL, if you've learned about this in the US. So the distributive law says that if you have a factor outside of a parentheses and addition or subtraction inside the parentheses, then you can distribute that factor by multiplying it by all of the terms inside of that parentheses, each one at a time. So in these two examples, we're going to expand the following by taking the factor that's outside the parentheses, which is here at 2, and multiplying it by the first term, which is 3x, and then by the second term, which is a 1. So note that the terms are the things that are separated by addition or subtraction, and each term gets multiplied by 1 time. So you're going to take the 2, multiply it by 3x, and that's 6x. Take the 2 and multiply it by the 1, which is going to be 2, and we've got a minus there. So 6x minus 2 is the expanded version of example A here. The second one's a bit trickier because now the factor that's outside is negative 3x, and then we're multiplying it by an x and by a 2. So negative 3x multiplied by x is going to be negative 3, if you write it out, negative 3 times x, right? That's what we're asked to do here. And x times x, we know we can shorthand that as x to the second power. So we're going to write this as negative 3x to the second power. That's the simplified version of negative 3x times x. And then we've got a negative 3x times 2, which is going to give us a negative 6x. And this is the expanded version of example B. All right, so these are our two expanded versions. So we are not solving anything. We're just rewriting the multiplication problem, remembering that parentheses with a number in front like that means multiplication, right? We're rewriting the multiplication, all distributed out. The product of two binomials, okay, so binomial is a word in math that means two terms. So if you notice in this property, each of these parentheses has two terms in it. The first one is A plus B, the second one is C plus D. If each of the parentheses has two terms in it, and you're multiplying them together, product, remember, means multiply, or the result of the multiplication problem. So we're looking to multiply two binomials together, and you can see that there's a pattern here. The answer has 4 terms in it. It's A multiplied by C, then it's A multiplied by D. So we're using the distributive property with A, and then we're also using the distributive property with B, and you see that B gets multiplied by C, and B gets multiplied by D. So this is what, if you've learned this in the US, is sometimes called FOIL, which stands for first, outer, inner, and last. And that's because if I show you that pattern again, you can see it's the first two things in each parentheses, it's the outer two terms, then it's the inner two terms, and then it's the last two terms. So first, outer, inner, last. But you might hear me refer to it as FOIL. It's probably better if we call it expansion or the distributive property. That's what we're doing, distributing A, and then we're distributing B. So in these two examples, we're going to start by distributing this x to the other parentheses. Notice that I'm not distributing it to the 4 because they're already in the same parentheses as each other, being added. I'm not multiplying x times 4. I'm taking the x and I am multiplying it by the other parentheses, one term at a time. So x times x, we talked about on the last slide, is x squared. X times minus 3 is minus 3x. And then we go to the 4 from the first parentheses and distribute that as well. So positive 4 times x is plus 4x. And then positive 4 times a negative 3 is minus 12. So just like the property says, I got 4 terms in a row here. But I know I need to be simplifying my final expressions back from our first lessons in this chapter or unit. So we see that there are two like terms here that can be combined. This negative 3x and this positive 4x have same variable, same exponent. I can combine them. I'm not going to try to combine the x squared or the 12 because they don't have like terms here, but I can combine the negative 3x and the positive 4x. So x squared plus 1x minus 12 because negative 3 plus 4 is just 1x, and that's the final simplified expanded version. Try another example over here. 2x times negative x would be negative 2x squared. We've got 2x times 3 is positive 6x. So I've taken the 2x, I've distributed it to the other parentheses. Now I have to distribute this negative 5. Trickier only because we're dealing with more numbers and more negatives. That negative 5 times negative x is going to be a positive 5x. Sorry about that extra line that appeared there. positive 5x, because negative times a negative is positive. And then I got this negative 5, and I'm multiplying it by 3 to give me a negative 15. And now again, I've got 4 terms in a row. I'm looking for 2 that I can combine. It's these 2 like terms in the middle. And so I can write this as negative 2x squared plus 11x minus 15. Now there are no more like terms to combine, so I go ahead and put a box around that. That's the most simplified version. There's a few, I mean, that's all of the expansion. There's a few special kinds of expansion, and this is one of them. It's called a difference of squares. So what's special about it is if you look in these 2 binomials, they look almost the same. So it's whenever you're multiplying 2 binomials that are almost identical, but one is positive and one is negative as the sign. One is minus and one is plus in the middle of the binomial. What's going to happen when we expand this is going to be kind of unique. So let's try expanding it using our property that we just learned about the product of 2 binomials. I'm going to distribute the 3x times the first 3x in the other parentheses, which is 9, and then x squared. 3x times 4, which is plus 12. Then I distribute, plus 12x. Then I distribute the negative 4 to the other parentheses, and I get minus 12x. And then negative 4 times positive 4 is negative 16. When I look for like terms to combine, I see that I have these 2 middle terms that combine to give me 0. And so they're not even going to appear in my final simplified answer. I'm only going to have 9x squared and the minus 16. So this is a special pattern where anytime you're multiplying 2 binomial expressions together that are identical except for the sign, you're going to end up with just 2 terms in your answer, because the middle 2 terms are always going to cancel each other out. It's going to be a minus and a plus that always produces 0. The reason, as the question at the top asks, the reason this would be called a difference of squares is not because of this, right? This is not a difference of squares. In fact, that word, those words might be confusing to you. But if we look at this final answer, this is a difference, right? Difference is the word that means subtraction in math. So the difference, right? Difference between 8 and 5 would be 3. It means subtraction. So this is a difference of what we have here are 2 perfect squares. What is a square? So a squared is what we sometimes would call this, right? X squared. Or if I had this, we'd call it 3 squared. And if you look at the 2 terms in our final answer here, these are actually both perfect squares. This is 4 squared, and this is 3x squared, which is, of course, how we got them to begin with. When we look back up to the parentheses, we took the 3x and multiplied it by itself. That is squaring something. And we took the 4 and we multiplied it by another 4, and that is squaring something as well. So we ended up getting the square of 3x, the square of 4, and putting a minus sign between them. If you want to memorize that shortcut to jump to the final answer, I'll throw up another example real quick. So if you had something like, let's say, 2x plus 5 and 2x minus 5, and you notice right away, oh, I'm in that special pattern where it's going to give me a difference of squares. I can just square the 2x, and I can square the 5, and I can stick a minus sign between them. And then I just have to simplify. I know 2x times 2x is 4x squared. I know 5 times 5 is 25, and I stick that minus sign between them, and I've gone straight to the answer without doing the FOIL pattern, or the binomial expansion pattern. So if you recognize it and you want to try the shortcut, you can, or you can always go through this step of expanding it to all 4 terms and then simplifying it to this. You've got those 2 options. Here are 2 more examples of difference of squares. If you want to pause it and try these out, I'll show what the answers are quickly. This is going to end up being x squared minus 16 when everything is simplified. And this one's going to end up being 9x squared minus 4 when everything is done and simplified. There's another special pattern, and that would be perfect squares. And this actually is talking about the original setup of the problem. So this is a perfect square trinomial. These are both perfect square trinomials, meaning in the end, they're going to turn into trinomials, though there will be 3 terms in the answers, like the ones we saw a few slides ago. And again, we can follow the same pattern that we've learned, the binomial expansion pattern. We don't need to memorize a shortcut, but it's another one that has a shortcut if you want to take the time to learn it. So first, you might notice it doesn't even look like a binomial times a binomial, like the other ones we've been doing. Except for that, if you remember what a squared means, it means take the base and multiply it by itself. Well, here the base is 2x plus 1, because that whole thing is being squared. And so what I meant to do is actually multiply it by another 2x plus 1, right? Take the base and multiply it by itself. I want to show in red what this is not. It is not this. So we have learned properties of exponents, where we take the exponent from the outside and we bring it inside. It is not that. The reason why is because when we learned that property, there was no addition or subtraction. We were not dealing with binomials. We were dealing with something like 2x y to the third, and then outside there might be a squared. And then we'd be bringing it in, bringing it in, bringing it in. So notice what's inside the parentheses had no plus or minus. That's when you can bring in that 2 and use your properties of exponents to square everything that was in there. When you've got plus or minus in the parentheses, it is a binomial expression, and you have to use this expansion pattern in order to simplify it. So I've written 2x plus 1 twice, and I'm going to use my distributing rule. I'm going to take the 2x and multiply it by the other parentheses. I'll get a 4x squared. I'll get a plus 2x. Then I'm going to take this 1 and distribute it to the other parentheses. I'll get another plus 2x, and then I'll get a plus 1. So we're going to end up with 4x squared, which is the first term squared, plus 4x plus 1. All right, so that's the simplified version. It's called a perfect square trinomial. We'll try one more example, just so you can see it done again. We're going to take the 3 minus 4y. The first thing I recommend that you do is write it out twice. Got 3 times 3 is 9. 3 times negative 4y is negative 12y. Again, a negative 12y, so you should be noticing the pattern that the middle two terms are always going to be identical. And then we get negative 4 times negative 4 is plus 16 and a y squared. This one might look a little backwards to you, but that's okay. The order is okay like this. So we'd have a 9. We combine those middle two, we're going to get a negative 24y. They don't cancel each other out because they're both minus. And then a plus 16y. And we can leave it in this order, even though it looks backwards to us, but it's actually okay to leave it in that order. So if you, we can actually skip this slide. This is just for further practice, but we're not going to be doing examples like this in this set of notes, so we can actually stop that video there.